Blah, 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 out of 8. Blah, 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 out of 6. Total out of 14. Tan in quadrant 3. Since it is quadrant 3 and tan is positive, x must equal -3 and y must equal, I lie, x equals -5 and y equals -3. Yes? So that means our hypotenuse is the square root of 25 plus 9, which equals the square root of 34. So sine equals -3 over root 34. Cos equals -5 over root 34. And theta is, I lie, 211 degrees out of 3. Any questions? Excellent. Cos is negative in quadrant 3, which means that x is -5. Y, we don't know. H equals 8. Y is the square root of 64 minus 25, which is 39. Root 39. I already had the cos. Sine is then therefore root 39 over 8. Tan is then root 39 over -5. No. Quadrant 3. 1, 2, 3. Tan has to be positive there. What have I done wrong? X is -5. Hypotenuse is 8. Oh, the y is negative root 39. There we go. That's why. Negative root 39 and -5 gives you positive root 39 over 5. And your theta is 231 degrees. Yeah, yeah? Yeah, yeah. Two possible locations of sine. Where is sine positive? It has to be here or here. So there's the 5, there's the 5, there's the 13, there's the 13. 1 mark for the drawing. What are the two possible values of cos? -12/13 and 12/13 for 1. Because when you do Pythagoras, you find that has to be 12. Find the values of theta, shift sign that, and you'll get both of them. 23 and 157 for 1 mark. Making that out of 3. If cos is -1/3, find all the values of theta. If cos is negative, it must be over here, yes? So all you got to do is shift cos that, and you find that you get whatever you get. Shift. What is it? Shift cos, oh man, clear. Shift cos of -1 divided by 3 is 109. So that's 109, right? Which makes this 71, which makes this 71, which makes this 251. Yeah? Yeah. So 109 and 251 for 2 marks there, because you had to do them both. And that makes that whole page out of 11 by my count. 2 and 3 is 5, 6, 11, making the whole thing out of 25. Give yourself a mark, and I'll get them later today, hopefully. Now, today's lesson is not anything new. You actually already know this. There are 2 triangles that work very, very, very well for us. 45, 45, 90, and 30, 60, 90. So, before we go any further, with your calculator, tell me the sine of 45, the cos of 45, and the tan of 45. Remember, sine is O over H, cos is A over H, and tan is O over A. What do you get for those values? When you do your calculator, you're going to get a crazy decimal. Just give me the first 3 decimal points for any of them that you get. Who has hit the 3 numbers for me? Or the 3 decimals? Or the 3 buttons? What is the sine of 45? Burke. 707. 0.707. Yuck. I don't know what that is. Barf. What's the cos? Holy crap. What's going on? What's the tan? 1. Excellent. Tan is opposite over hypotenuse, yes? Where in this triangle are the thetas allowed to be? It's got to be there and it's got to be there, right? And since they're both 45, they're going to be the same, yes? So the tan of both those thetas is O over A, correct? What is the easiest way to show me the number 1 if you're doing it by division? What do we know about these two sides? What? Pardon me? They're equal, right? So what's the easiest number to put there? 1. That has to be 1 and that has to be 1, because 1 divided by 1 is 1, right? Now, if you know that side and you know that side, do you know this side? How? How?
Merry Christmas.
Merry Christmas! It's a Christmas miracle. Have some cookies. Hey, Mr. Como. Hey, Mr. Sadu. Hey, Mr. Peters. Cookies for everyone. Cookies for all my friends. You get a cookie and you get a cookie. It's raining cookies.
Raining cookies. So get a math question for this. How many cookies squared?
It is a linear relation.
The more cookies you eat, the higher your blood sugar.
Look at this.
Troy Weihnachten.
Oh, Tannenbaum. It's the extent of my German. 1, 2, 3, 4, 5.
Cookies?
Auf Wiedersehen.
What lies are these up there, Schnee?
Oh, listen to this guy. I think he insulted me. I think he did. Merry Christmas, guys. All right. So if this is 1 and this is 1, what's this? No. No. What is it, Megan? Square root of 2. Everybody cool? So now, do we know what this really is? It's not 0.707. It's 1 over root 2, isn't it? And what's this guy? 1 over root 2. Everybody cool? All right, now, 30, 60, 90. While you're at it over here, I'm going to use 2 different colors. Tell me the sine of 30, the cos of 30, and the tan of 30. And then the sine of 60, the cos of 60, and the tan of 60. And you're going to see something kind of funky happen there. What is the sine of 30? No, you use your calculator. I need the calculator. Antonio, I'm going somewhere with this. Sine of 30 is what? 0.5, right? Which is 1/2. We know that as a fraction, right? Okay. What's the cos of 30? It's barfy, 0.866. We don't know anything with that. What's the tan of 30? 0.57. Okay. Barfy. What's the sine of 60? 0.866. Hey, wait a minute. What's the cos of 60? Hey, 1/2. What's the tan of 60? 1.73. All right, so now what there can we work with in a triangle form? We can use the 1/2s, can't we? Now, 30 is which of these two angles? Which is the blue theta? Is it this one or is it this one? This is blue theta, right? So this is 30. Everybody cool? Which makes this green theta and 60, yes? So what are the sides we know? We know that the sine of 30 is 1/2. And sine is opposite over hypotenuse, isn't it? So what does that make this? 1. What does that make the hypotenuse? Sine is opposite over hypotenuse. 2. Can we use Pythagoras to find the bottom here? It is √3. Everybody cool? Which means the sine of 30 is 1/2. The cos of 30 is √3/2. And the tan of 30 is 1/√3. The sine of 60, √3/2. Cos of 60, 1/2. Tan of 60, √3/1, which is just √3. Everybody cool? How does this help us? Well, anywhere we can put these triangles on our Cartesian plane means we automatically know the values, don't we? Oops. We should have taken these and written them here. But I didn't. But that's what we were doing. And then 90, of course, has its own rules, yes? Right? We know about 90. So how does this apply to us? When we want exact values, we do this. Terminal arm, reference angle, special triangle, whichever one it is, 30, 60, 90, or 45, 45, 90. Label it, and then do the trig. It sounds like a lot, but it really isn't. We'll start with a super easy one. Sine of 45 is right there, right? Since I know that's 45, I know that that's 45, and I know that's 1, 1, and √2, correct? So now, all you got to do is tell me the values. Sine is 1/√2. Cos is 1/√2. Tan is 1. That's an easy one, right? 45, 45, 90 is real easy to work with, right? 60, 30, 60, 90 causes trouble. So 60. Now, remember, this is the triangle with which we are working, yes? 30 is down here, 60 is there. What do I have to do to this triangle to put it over here and work with cos 60? I got to turn it, don't I? It's going to end up going up like this, yes? Making this my 60, correct? Now, you guys are smart kids. If this is my 30 up here, and I know this triangle is 1, √2, 3, you should be noticing that the 1 is always across from 30, because that's the smallest side, right? So what does that make this distance right here? 1. What does that make this distance here? √3. I wrote it as √2. I did that backwards. It's 1, 2, √3. So this is my √3, and there's my 2. So now I can do it really easily, right? Sine is √3/2. Cos is 1/√2. And tan is √3/1, which is √3. Can everybody do it in quadrant 1? It's pretty easy, right? Everybody's cool? All right. Now what happens with C? which I'm going to do in blue. It's down in quadrant 4, yes? So I got to come all the way around. It's down here. What is this? If this is 330, what's this? 30. So if that's 30, what's this? 60. Now I know the triangle, right? What's across from 30? 1. What's across from 60? Root 3. What's the hypotenuse? 2. And then we're good, right? Can I leave it there? Everybody can make the fractions, yeah? All right, I'm going to do D, and then you're going to do E through H. D, 225, that's out here, yes? If this is 225, what's this? 45, which means I'm dealing with a 45, 45, 90, right? 1, negative 1, negative 1, and root 2. So then I do my sine, cos, tan. Sine, negative 1 over root 2. Cos, negative 1 over root 2. Tan, 1, because negative 1 over negative 1. Yo.
So knowing this in C, would it be root 3, 2, and then negative?
Yes. This should have been negative 1. Is everybody cool? Okay, you guys do E, F, G, H. Go. If you totally don't know how to start, I will draw them for you, but not put in any numbers. Computer's frozen. I'll wait a moment for people to get that down. Has everybody tried at least one of EFGH? Has everybody tried at least one? Okay. So if I go all the way around and that's 240, what's this? 60, which means that's 30, which means what's across from 30? 1, but it has to be negative 1 because I'm going left. What's across from 60? What's across from 60? Root 3, but it's got to be negative because I'm going down here. What's the hypotenuse? 2. Can I leave the fractions to you guys? Is that cool? All right. So, red. If all this is 210, what's this? 30. So what's this? 60. So what's this? Negative root 3. What's this? Negative 1. What's this? 2. And then you make your fractions. Everybody good? Okay, the blue one. If this is 150, what's this? 30. Which means what's across from 30? Positive 1. The angle is 60. What's across from angle 60? negative root 3. What's my hypotenuse? 2. And then I do my fractions. If all this is 315, what's this? 45. Across from 45 is 1. Positive or negative 1? Negative, because it went down. Across from 45 is 1. Positive or negative? Positive, because it went right. Hypotenuse? Root 2. Hypotenuse is always what? Positive. Is everybody good with working angles to fractions? Everybody? Good enough? Like you've got a vague idea, you could figure it out if you sat down and had some practice with it? All right. Now let's work the other way. Now I know the angle. I know the ratio. So, if cos theta is negative, where can it live? What are the two quadrants in which this theta can be? 2 and 3, absolutely correct. And since it's cos, I know that the hypotenuse must be 2, yes? And cos is adjacent, right? Or x over 2, yes? So where is the x? Right here. Negative root 3. Everybody with me? So, if that's negative root 3 and that's 2, what's this? 1. What's this? Negative 1. So, knowing this triangle, what angle is in here? 30, because it's across from 1. So what's this in here? On the bottom triangle. 30 as well. Are those thetas or are those reference angles? Those are reference angles. Do I want reference angles or do I want theta? Do I want reference angles or do I want theta?
Oh, never mind. Yeah.
What do I want? Theta. What is red theta to there? What? 150. Why, Sukpal? Yeah, because 180 would go all the way to the other x-axis, but I had to go back 30. What is blue theta? $210. Why, Jazkirat? Because it's 180 plus 30. Gouda? All right. Where can sine be if it is positive? Has to be here or here, yes? What do I know about sine? It's y over hypotenuse, right? So my hypotenuse is root 2. My hypotenuse is root 2. My y must be 1. My y must be 1. So what triangle is this? 45, 45, 90, right? So what is this in here? 45. What is this in here? 45. What is red theta? Red theta equals 45. What is blue theta? 135. Why? 180 minus 45. Is everybody cool with that? Try it for C. Because C is Tricky McTrickleton. He is so cunning you could put a tail on him and call him a weasel. Hey, Sarav, where can tan be negative? I am hearing Antonio teach this to you right after I teach it to you. You're getting a double shot. Where can tan be negative? Quadrant 2 and 4. So I have to go down here or up here, yes? Tan is y over x, right? So what is the real denominator here? 1. So it's y over x. So that means this must be 1, negative 1, and this must be what? Positive 1. Does it matter how I draw it? Or is the sketch just to help me? It's just to help me. What's always across from 1? 30. So what must this be? 60. What's always across from 1? 30. So what must this be? 60. So since I know those two, do I now know red theta? Is it 150 or 120? Okay, 2 other people just said them both again. Which is it? If this is 60, what's this? 120. I drew it badly on purpose because drawing doesn't matter. It's just to help. What then is blue theta? 300. Why is red theta 120? 180 minus 60. Why is blue theta 300? 360 minus 60. Is everybody good? That's it. There's not even any textbook work with it. It's just page 164 and 165. And then you're done SOHCAHTOA. After that, we start something that for almost all of you will probably be totally new. John has seen it. Max has seen it. Sophie has seen it. Yes. And Julia and Antonia will probably have seen it because they're from elsewhere. And Yoon will have seen it. Maybe. Is everybody good? Huh? Does it say assignment? Is it for marks? Why would you do that to us, Mr. Myers? Why would you give us something for marks without giving us practice? Because how easy is it? Right? You don't even need, you're not even doing any calculations. You're just turning a triangle. You don't even have any choices. It's got to be 1, root 2, or 3. Or root 3. Just depending on which triangle you have. Hey, wait a minute. I didn't want it. Oh, man, we're a day ahead. Oh, well, you guys are going to... I got something for you to do tomorrow. Don't you worry. I'll warn you all now. Tomorrow you're doing a SOHCAHTOA Trig quiz. That is worth what? Because it's a quiz. Oh, on the last day you're doing something that isn't worth a thing? Stop it, Mr. Myers. But of course you're all going to be here because you have brought your sleigh full of presents for me. As you can see, my Christmas tree is very naked under there. I do have one present and one card that I have strategically placed to look bigger than they are by standing them up vertically. They're lonely. Yes. And remember, Christmas gifting, it's in the joy of giving, which is why it's a test. When you give someone a Christmas gift, they are subtly judging you when you give it to them. Because if you give them something that they absolutely hate, that shows that you do not know them. And that hurts. I know this from experience, Max, because all my life people have asked me for Christmas lists. And I've always said, no, just get me a present. I'd want to be surprised. And then people get mad and they say, give me a Christmas list. So I give them a Christmas list. And then they don't buy me anything on the list anyway. So why the heck did you ask for a list? No, because you never buy, and they're always like, well, none of those gifts on your list spoke to me. I didn't think you would want, like, what? Oh.